This is the example from slide 12. We're given that the enthalpy of vaporization for benzene, H vape, is 30.7 kilojoules per mole. And we're told that the boiling point of benzene is 80.1 degrees Celsius. And we're trying to find the entropy of vaporization, the delta S, for this phase change. All right, and we're given a formula, delta G equals delta H minus T delta S. Okay, and as I said at the presentation, if you're at the point of the phase change where both the liquid and the vapor are existing in solution together, it's at equilibrium, and delta G is equal to 0. So if delta G is equal to 0, we can rearrange this equation to say delta H equals T delta S, and delta H over T equals delta S. All right. Add the T delta S to both sides, and then divide both sides by the T. So then we can use the delta H vaporization we were given in the boiling point to get the delta S for the vaporization. The only tricky thing here is going to be the units. All right, we were asked to calculate this in units of joules per mole times Kelvin. All right, so the delta H that we use is going to have to be in units of joules per mole, and the temperature we use is going to have to be in units of Kelvin. All right, so before we go any further, I'm going to have to do some conversions. All right, 80.1 degrees Celsius plus 273.15 Kelvin is going to give us a temperature of 353.3 Kelvin, and our 30.7 kilojoules per mole. All right, we know that in every 1 kilojoule there are 1,000 joules. Kilojoules cancels with kilojoules, and this gives us 3.07 times 10 to the 4th joules per mole. All right. So now that we've got our units straight, we can go ahead and plug into our equation. Delta S equals delta H, which is 3.07 times 10 to the 4th joules per mole, divided by our temperature, 0.3 Kelvin. And this should give you an answer of 86.9 joules per mole times Kelvin.